The project file for the gRPC API has a reference to the NuGet package grpc.ASP.NET Core, which contains all the classes surrounding gRPC we need, as well as the tooling that generates the code from the proto file. We configure the location of the proto file in this line, specifying that we want generated code for the server side of the API. When building the project, the tooling will take the proto file and create a base class for us called products base. Products was the name of the service in the proto file. We can now create our own class deriving from this type and override the two methods. Apart from the expected request object, we also get a server call context object, providing additional information about the request. All we have to do now is create a response object, fill it with the needed data, and return it. In Program CS, we have to add the gRPC classes to the dependency injection container and then take our service class and map it to an endpoint. We only need one endpoint, not a multitude of them like with REST, because we call a method by name using that one endpoint. As the client, I've taken the MVC project we saw earlier. I'm not showing the Blazor WebAssembly project in this case because it requires a configuration that is a little bit more complex. But if you're interested, I've included the solution in the GitHub repository. The project file of the MVC project has a reference to the same NuGet package, and it points to the proto file. I've included the proto file in the project using a symbolical link. Basically, what you're seeing here is just a reference to the file in the API project. By default, the generated code is for the client, so no need to specify that. In the Program CS file, I added generated client class to the dependency injection container by calling add grpc client. That enables us to configure the client. In this case, I just specify the URL where the API lives. In the controller, we can now just inject the client and call the methods on it. Also note that with gRPC, there's no need to share something other than the contract between client and API. The product type here is also generated from the proto file. Here are the differences between Web API and gRPC. REST using Web API is content first. The line of thinking here is, we have a piece of data, and how do we get that across? This results in the message content being human readable. With JSON, we can perfectly read the data that is coming across the wire. We can see the property names in the JSON as well as the values. That is convenient, but not very efficient. We are repeating property names over and over again, and having messages in a text format is also not optimal in terms of performance. REST APIs use HTTP. That means the caller has to know how HTTP works and what the conventions around REST are. The advantage is that the client doesn't have to know any implementation details, including the method name, which results in a looser coupling between API and client. It's easier to update the API with this looser coupling. With gRPC, we create the contract first and worry about the implementation of the data transfer later. The data transferred is not readable since it's binary and optimized. That makes gRPC faster than REST-based APIs. Just the contract is human readable. And since we work with convenient client classes, the consumer of a gRPC API doesn't have to know anything about the underlying HTTP protocol. It just calls the method and everything else is handled by the generated code. But this results in a tighter coupling. All clients have to know exactly how the API sticks together. The contract is great for that, but when it changes, all clients have to be updated. For that reason, gRPC is more suitable for APIs that are used within the same organization. REST APIs with Web API are more suitable for public APIs. Again, that doesn't mean you have to choose. You can have both. There's nothing preventing you to have both Web API endpoints as well as a gRPC endpoint in one API project. Now you can share the Web API endpoints with external parties and use the more efficient gRPC internally. I've kept the back-end and front-end applications separated in this course, which is the way to go with larger applications. But since the underlying technology is ASP.NET Core for both front and back-end applications, it is also possible to create, for example, an MVC application and add Web API endpoints to it. That can reduce complexities around deployment and costs of hosting. There's one technology left to discuss. Let's see what SignalR is. Normally, a request is initiated by the client, for example a browser, to the server. But what if we want to send a message from server to client? For example, these two browser windows represent two users on different machines. When one of the users adds a new product, the other browser is notified and automatically adds the new product to the list. The only way to do that is to have the server application, in this case an API, created with Web API, contact the client application, in this case a Blazor WebAssembly application, directly. SignalR makes that possible. It is a technique mainly used to call methods on clients from a server application. The server application could be server rendered, such as with an MVC or Razor Pages application, or an API made with Web API or gRPC. The class present in the server application that facilitates this is called a hub. Using the hub class, messages can be sent to all clients, or one, or a particular group. To make server-to-client calls, SignalR uses existing web techniques like WebSockets that facilitate two-way communication between client and server. When WebSockets isn't supported by client or server or something in between, SignalR facilitates a fallback to all the web techniques that make that possible. Like gRPC, SignalR also uses remote procedure call. We can define a method on the client. It could be in a browser application done with Angular, React or Blazor WebAssembly, or in any other type of application. SignalR clients are not restricted to web applications. Using the hub, the server application can now call this method. And of course, passing in parameters is supported. Since we now have two-way communication between server and client, we can also turn things around. Now the hub has the implementation of a method that can be called by the client. So theoretically we could just build an API, like the one done with gRPC I showed you. This, however, is not common practice. First of all, SignalR doesn't have something like a contract to define the API and the types. A method is basically called by passing in a string. Also, the permanent two-way connection is often less reliable than a traditional API that creates a connection for each request. And securing that connection also has its challenges. For these reasons, SignalR is mainly used to do non-critical things like sending messages to browsers so they can update their UI. I've added SignalR support to the Web API application using minimal APIs. In Program CS, notice the line that adds SignalR support to the dependency injection container, and scrolling down, I've mapped a hub called Product Hub to the endpoint /Product Hub. Since we use RPC, again, just one endpoint is needed. The hub is a class deriving from the hub base class provided by SignalR. The methods in the hub are callable by the client. In this case, there's a send message to all method that takes a message. We will call this method from the client in a second. It uses the client's property on the hub class to send the message to all connected clients. The first parameter of send async is the name of the method to call on the client. and the second is the message itself. To avoid confusion, here's a schematic overview of what is happening. A client can call the sendMessageToAll method on the hub, which will send the message to all connected clients by calling the message method on each client. So this messaging feature is nice, but we also want the API to notify all clients when a new product is added, letting them know the product details. The place where the product is added is in the code that handles the post request. We want to access the hub here, so we can call a method on the client passing in the product. We can make that happen by injecting an iHub context of Product Hub, which can then be used to call the new product method on the client. As a parameter, the method will get the new product. And again, serialization of the product type is automatic. The client is the Blazor WebAssembly project. The only new code is in the index page. It uses the Hub Connection Builder class to build a connection object representing the connection to the hub. After that, the methods that can be called by the hub are specified. We have the new product method that gets the new product as a parameter. The implementation of it is to just add it to the collection, after which Blazor is notified that something has changed, so it can automatically update the UI. We also call the hub method sendMessageToAll here, sending a message that the product was added. As we saw, the hub will call the method message in response, for which we also have a handler. The final line is opening the connection. That's a wrap of the main features in ASP.NET Core. Let's take a look at what you could do after watching this course. Wow, that was a lot of information to take in. Like I said in the beginning, this course is meant to sum up what ASP.NET Core can do. You should have a pretty good idea now. But there's more involved before you can actually sit down in front of your keyboard and start creating ASP.NET Core applications. This module is here to help. We'll see what the next steps can be. This slide should look familiar by now because I used it in every module. And I'm using it now to summarize what we have learned. With front-end applications, we learned that although applications made with MVC and Razor pages have a different structure, they are both server-rendered front-end applications. The server does the UI processing. With Blazor, a way to create client-rendered front-ends, that is done in the browser. At least with Blazor WebAssembly. With Blazor Server, the rendering is done on the server. But they both offer the same smooth single-page experience to the user, and the components you write are interchangeable, as long as you don't code features a browser can't support. In the back-end realm, there are two options, Web API or gRPC. We concluded that Web API, using the REST paradigm, is great for both internal and external-facing APIs. But because all clients have to update when the contract changes, gRPC is more practical with internal APIs. A big plus for gRPC is its performance. It can be used in an architecture with APIs that support the front end, but gRPC is also great in a microservice architecture. SignalR is a technology that enables two-way communication between client and server. It should be viewed as an add-on technology to the front and back end possibilities. A common scenario where it is used is to let the client, which can be a browser or any other application, know that something happened in the server application, which can be either a server-rendered front-end or a back-end application. An important thing to keep in mind is that all these technologies run on the same foundation. They are all using the ASP.NET Core engine. They all use dependency injection and middleware in the same way, for example.